In this video, we'll be using the Nitric framework to build a serverless GraphQL API that interacts with and stores profiles in a document collection. Because GraphQL APIs rely on only one HTTP endpoint, we want this to be highly scalable, performant, and reliable to handle a large number of requests. Serverless compute, like AWS Lambda, meet all these requirements due to the auto-scaling and uptime guarantees that the cloud provides. GraphQL is an alternative to REST that was developed by Facebook to handle the need for more flexibility and type safety when interacting with an API. To illustrate the difference between them, we'll be building our API with the exact same specs as the Profiles API from our REST API guide. The beauty of GraphQL is that you can choose which properties you want from your API, even nested objects. This attempts to solve the problem of under and overfetching that REST APIs commonly have. This is when you either fetch more data than you need or not enough data, so you have to make another API call. So let's get started. You're going to want to make sure that you have both Node and the Nitric CLI before you start. We'll then start by creating our Nitric project. Open up a terminal and use the Nitric new command. This will prompt us for a name, template, and function handlers. We'll name our project Nitric-GraphQL and use the TypeScript starter template. The function handler is a glob that points to where our functions are. For this, we'll just use the default, as all our functions will be .ts files in the functions directory. Once the project is made, we'll open up the hello.ts file and remove all the contents to start. We'll then resolve our dependencies with yarn install and add the GraphQL package from npm with yarn add GraphQL. GraphQL requests are type safe because they get validated against the schema we define. Let's start by defining this schema. Import build schema from the GraphQL package at the top of our function file. We'll define our schema using the build schema function, which we imported just before. This will take in a string with the entirety of the schema defined in GraphQL schema language. We'll first define a profiles type, which has a non-nullable ID, name, age, and hometown. You define it as non-nullable using the exclamation mark at the end of the type. We define our arrays by wrapping a type in square brackets. So for this first one, we have a profiles array. Both the array or profiles could be null. This means that the entire thing could be null or it can contain null. Our next type will be that the array can't be null. The next type, which is the reverse of before, is that the profiles can't be null, but the array can be null. Our final type is that neither the profiles nor the array can be null. Let's get to writing our first query. This is done in a query type, so this will wrap all our query functions. We'll first define the getProfiles query with a return type as an array of profiles where both the array and the profile can't be null. So this means that we'll have an exclamation mark on the inside and an exclamation mark on the outside. This means that when we write our function and implement it, we will return an empty array if there are no profiles, rather than returning null. We'll also want to write a getProfile query, which just gets a single profile by its ID. This will take in a non-nullable ID parameter of type ID and a profile return type. We'll leave the profiles as nullable as there may be no profile that matches that ID. So let's get to writing some TypeScript. So this is going to be writing a few types to match our GraphQL schema so that we can actually use the types within the code. If you do not want to write these types yourself, you can use a tool like GraphQL Code Generator, which will generate all the typings for you. I recommend this if you're going to make your application more maintainable, as keeping your GraphQL schema and TypeScript typings in line can sometimes be frustrating, especially when you're adding stuff like Prisma ORM on the top and you just have types everywhere. So anyways, let's write our profile interface. This will, like the GraphQL schema, have an ID, name, age, and hometown. All of these can't be undefined like our schema. So it's pretty simple. Let's just make sure we export it so we can use it in our other file. We also want to define a type for our profile without its ID. This is because when storing our profiles in the collection, the ID will be a reference to the document and the name, age, and hometown are the actual properties on the document. So we want to separate these for ease of use with both the collection and when we get to creating and updating our profiles. So let's create our first resolver. Resolvers are going to mirror our schema definition, which in the schema, we've defined a getProfiles and getProfile query. When we implement them, they will have the same parameters and the same return types as within the schema. We're going to want to put our profiles somewhere. So in this case, we'll be using a Nitric collection. So let's add it as an import. We then want to create a collection using this Nitric collection function named profiles with permissions for reading and writing. When we do a deployment or local run, the Nitric collection within our code will be automatically detected. The configuration name and permissions will be grabbed and then used to provision a cloud-based collection on the cloud of your choice, AWS, GCP, or Azure. In the case of a local run, a mock collection implementation for testing will instead be provisioned within the file system. So now that we actually have a place for our profiles to go and get fetched from, we can start writing some resolver code. So for each of these resolvers, it's important to know that they receive an args object, which will have the arguments from the GraphQL query. So let's write a getProfile async function, which will take in this args object, which will destructure to receive just the ID and return a promise with a profile or null. So the idea with this is that we'll try to query our Nitric collection, and if it doesn't appear, then we will just return null. So we can start by using the collection to get the document with that ID by doing a collection.doc with the ID.get. We want to make sure that we await this, as this is an asynchronous call. This should return a profile if it exists with only its name, age, and hometown. We can then return this as JSON, spreading the profiles so the JSON object remains flat. We'll wrap this in a try catch, as if a document with that ID is not found, it will throw an error. We'll account for this by catching the error and returning null, and we'll also want to log the error for monitoring. As you can see, we're still getting an error on the return type. This is because the collection doesn't know what type of documents it's storing. So let's import profile input so we can let the collection know that it's storing profile input type documents, which just contain name, age, and hometown. Now that we have a get a profile by its ID function, we also want one for getting all the profiles. So this is obviously going to be our get all profiles function. This again will be asynchronous. It will take no parameters and return a promise with an array of profiles. Because we defined our schema to make this profile non-nullable for both the array and the profiles, then this will be a non-nullable promise. So this will query the entirety of the profiles collection using the .query.fetch call. We also want to await this because it's asynchronous like last time. This will return an object with all the documents on the collection. We then map over the results document from this query, converting each document from a document object to a profiles object. So the document object from Nitric looks like this, and our GraphQL query expects it to look like this. So when we map over it, we're just going to pass in the ID into the object and then spread the contents of the document onto. So let's create a resolver object. So this is just going to be an object where the keys are the name of the query and the value is the function that is going to actually implement that query. In this case, we can just pass it directly in because the name of the functions that we've defined actually match the query schema. We can then build our GraphQL handler. So before setting up the GraphQL handler, because it's going to sit at the endpoint /GraphQL, we actually need an API first. So let's import the Nitric API at the top and then define the API, naming it public. We can then define the actual route by doing profile API.get and then the endpoint, which will be /GraphQL. It then takes in an async context, which stores the request and response objects. So we're going to use this to destructure our query and variables from the request JSON by doing context.rec.json. This handler is going to accept a schema, which we've defined before, then the source, which is the actual source of the query, which is going to come from our request JSON, and then the array for our resolvers, which is the root value. So basically what this handler does is validate the query against the schema and then work out from the query what resolvers will need to be used to satisfy the query. In the case of a getProfiles query, the getProfiles resolver will be used as it matches in name. So this call to the GraphQL handler will return results from the resolver with the results as the JSON body, like so. So now that we've actually defined our API and the GraphQL route, we can do a local test. So open up a terminal and type in nitric run. It's going to first gather the configuration from our code, which are our nitric resources, such as the collection and the API. It's then going to build dev images for all of our functions. It's then going to start these containers, which are our functions, and then it's going to output an endpoint for hitting our API locally. For a local run, all the APIs sit at the API's subroute with the name of the API as another subroute to this. So in this case, our API name public sits at localhost port 9001/APIs/public. If we were to name our API profiles, it would sit at /APIs/profiles. Let's open a HTTP client to make some queries. I'm going to use Thunder Client, which is a free VS Code extension that is an alternative to Postman, but feel free to use whatever you like. Preferably, you will want this HTTP client to have GraphQL support. So we'll make a new request and type in our endpoint at the top. This will be localhost port 9001/APIs/public/GraphQL, again, because that's what we defined earlier. We're then going to go to the body tab and then change the type to GraphQL, which will give us both the query section and the variable section and give us some syntax highlighting. So obviously we're going to be using the GraphQL query language to hit our API. This is quite intuitive, so if you don't know it, just keep following along. The queries are going to resemble the GraphQL schema we wrote earlier. So to get our profiles, we're going to do the query key followed by getProfiles, which is our actual resolver. And then within the resolver, we can choose which properties we actually want to return. So this is the beauty of GraphQL, which I talked about earlier, which is removing the problem of under and over fetching. It doesn't really matter because we know that there's no profiles in there, so it's just going to return an empty array. We can then do a getProfile query, which is going to get a profile by its ID. Again, this is just going to return null because no profile actually exists. It's going to be almost identical. So let's do getProfile, and then we want to set some parameters for an ID, and we'll just put the ID as 1, 2, 3, 4. We can then obviously set the properties that we want. So we want to be able to actually add some profiles to our collection so that we can get them. If we go back to our schema, we can add a mutation type. Mutations are basically the same as the query types. However, if a query intends on mutating the data in any way, then it's best practice to use the mutation keyword. This is to set a convention that side effects will be caused when running this query, whereas a simple GET request using a query type will be idempotent. So let's think about the implementation of this create profile resolver for a second. So we're going to want it to generate an ID and then accept the information about our new profile. We're then going to want to add this to the profiles collection because we don't actually want to pass the ID in with the profile information and instead want the resolver to generate it for us. We're going to want it to create a new input type called profile input. This will be identical to the profiles type but omitting the ID. So let's create our mutation type. This is just type mutation and then the name of our resolver, which is create profile. It's going to take a profile parameter, which is going to be a non-nullable profile input, and then return a non-nullable profile. This is non-nullable because the return will just be the generated ID with the profile input. We can then write the implementation for this resolver. This will be an asynchronous function that accepts a profile input object and returns a promise of a profile. We'll then generate the ID using the uidv4 package. So let's add it using yarn add uidv4 and then add it to the top of our file importing the uid function. We call this, get an ID, and then use that ID to reference a document. This will set the content of the document as the profile that was inputted into the resolver. We'll then return a new profile object with the ID and the profile spread. So let's just make sure that we add the create profile function to the resolvers object and save our file. When we save it, it will hot reload the Nitric API, so you don't need to do another Nitric run. We can then test our create user object. So let's reopen Thunder Client and make a new request. So this is going to be the same endpoint as before, and then we can just change the body of our query to be a mutation. This mutation is going to be our create profile resolver, and we're going to pass in a name of Peter Parker, age 22, with a hometown Queens, New York. So when we send this request, it should return Peter Parker as well as the generated ID. Let's create 2 more profiles just to make sure that we have a complete set. So we have Tony Stark, age 50, hometown Manhattan, New York, and Steve Rogers, age 105, hometown Brooklyn, New York. We can then make a get all profiles request, which will get all their details, and then when we click send, you'll see all 3 profiles in the response. If you wanted to just get a single profile by its ID, you can copy the profile ID from the get all profiles request. You can then go back to a definition of the get profile query and then pass in this ID. We can query whatever properties we want and click send. So let's just create another mutation for updating a user. It's just going to be going back to our schema, going to the mutation section and writing an update profile resolver. So this is going to take in both an ID and the updated profile input object. It will return a new profile with the updated user profiles or null if a profile with that ID could not be found. You could alter this to be an upsert, which would either update it if it does exist or insert if it doesn't, but we'll just keep it as an update. So we're going to build the resolver now to mirror this with an ID and a profile input object, as well as returning a promise of a profile or null. So let's first attempt to set the profile object with the ID. We're going to make sure we await this again. And then we're going to return a JSON object with the ID and the profile. If this can't find a document with that ID, we'll want to catch the error that it causes. So let's wrap it in a try catch, and if it does catch an error, then we'll return null. We'll also want to make sure that we log the error just for future monitoring. So let's just add it to our resolvers so we can test it. We'll open Thunder Client back up and test that this works by requesting to update Peter Parker with a new object of Ben Riley, age 22, and hometown Las Vegas. So we'll copy and paste the ID from one of our previous requests and then send the mutation. This should return us with a Ben Riley profile, and if we query all the profiles, like before, Peter Parker will be gone and instead replaced by Ben Riley. Let's make one final mutation for deleting a user profile. So this will just take in an ID and return a nullable boolean. So the idea here is that our implementation is going to return void, but because GraphQL doesn't really have a void type or a null type per se, we just have to provide a nullable scalar. So in this case, we're just going to arbitrarily pick Boolean, as it doesn't really matter in the final implementation anyways. Our implementation is just going to be called delete profile with only an ID parameter, and it's going to return a void promise. We'll then use the delete method on our document, which will delete the document if it exists. This will just be queried by its ID. So let's just add it to our resolvers object and let's get to testing again. So let's reopen Thunder Client and then start writing our query. So this is just going to be a mutation query like the last two. We're going to do the delete profile resolver. We're going to pass in the Ben Riley ID from our previous requests. And then when we click send, this should delete our profile, returning a null response. With all this done, we are ready to deploy to the cloud. So let's create our stack file, which will hold our deployment configurations. You can optionally create multiple stack files to have a development and production environment, or a configuration for each cloud. Stack files are just there to give you the flexibility separate from the project config itself. Before you do your deployment, if this is your first time, you'll want to make sure that you have your cloud credentials set up. This will follow the same format as any normal AWS deployment. But you can follow the guides on our cloud reference page on nitric.io. I will leave a link in the description. So once that's done, we can actually do the deployment using nitric up-s and then our stack name, which in this case is dev. When this is deployed, you'll see the endpoint for the API gateway that was deployed to AWS. We can do some further testing against our cloud environment. Keep in mind, execution may go out of your free tier and cost money depending on which cloud you use. However, we'll do a quick create profile and get profile to verify it works. To reopen Thunder Client to do some testing. So this is just going to be identical to our local test as Nitric tries to replicate the cloud as much as possible on your local machine. So the only thing that will change is our endpoint. So we're just going to copy and paste this path and paste it in the Thunder client. And then we can go to our body, copy and paste our queries from before, and then we can do a create profile, press send. We should get back the profile that was created. We can then do a get all profiles, which should just return back this single profile. So we can see after we press send that we have the Peter Parker object. So this sort of verifies that we have created the object, and we can also fetch the objects. Once you're done with this, you can actually take your stack down using the nitric down command. So this is just going to be the reverse of the nitric up. It's just nitric down -s and then our stack name again, which is dev. And that's that. We have successfully created our own serverless GraphQL application, which can create, read, update, and delete profiles from a cloud collection. If this guide was useful and you want to see more of it, please leave a comment or reach out to us on GitHub or Twitter. Thanks for watching, and I'll see you in the next one.